All right, chemistry kids, Ms. Reinhardt and I wanted to spend, Ms. Hyde as well, probably, Ms. Anderson, we wanted to spend a quick minute talking a little more about physical versus chemical changes. We did that properties of matter activity a couple of days ago, and we noticed some common misconceptions that we want to kind of address today. First off, the activity said that a chemical change is something where the constituent components, whether it's the elements, or the compounds themselves, they stay the same. They can change, obviously, it's a physical change, but they are going to still remain themselves. They're not going to turn into different compounds or different substances. But one of the things in the note said that all phase changes are considered a physical change. So, for example, when an ice cube melts, the liquid is still water. It's still, still the same thing. When the liquid boil turns into a gas, it's still water vapor, even though it's kind of hard to see and find. It is still there. You think about boiling spaghetti at home. And so a lot of kids got that one correctly with the phase changes, but there was a couple others that we want to talk a little bit about. So the first one's actually going to take a minute. So I'm going to actually show you an example of a chemical change. And so what I have here is some copper sulfate. I'm going to add it slowly to a test tube. Note that the copper sulfate is a blue liquid. And then I'm going to add some steel wool. So steel wool is that gray metal color that we have. And I'm just going to gently, carefully place that into the liquid. And then we will come back and check on that in a couple of minutes, okay? All right, now the other one I want to talk a little quick about versus physical versus chemical changes. Get that one down there a little bit deeper. Okay. You had one about dissolving salt in water. Well, when you dissolve salt in water, are you producing something new? And you guys do this all the time at home. You think about when you're making spaghetti again, you put salt in the water, you're not creating a new substance. Okay? You're creating a mixture of salt and water. So this is not a chemical change. Okay? And the easiest way to think about that is think about, what did you make? You made salt and water. You made salt water. You didn't make something different. You made salt water. So it's still the same thing what you started with. So that is a physical change in there. Now, could I get the salt back out of the water? Can I have a reversible reaction, so to speak? Well, the answer in this situation is yes. Okay, you can. You can boil off the water, and then you'd be left with salt. That's basically how we make sea salt. The salt, the water evaporates away, and you end up with sea salt. You could do that at home, boil off the water in your spaghetti pot, and you'll bring the salt right back to you. Now, but a reversible reaction does not always mean that it is a physical change, okay? So if you have a reversible reaction, that doesn't necessarily mean it. So for example, ripping a sheet of paper. I still have two pieces of paper, right? It's still the same thing. That's a physical change. But is this reversible? No, I'm never going to be able to get that paper back together perfectly like it was before. Okay, so not all physical changes are reversible, and that's a really important key thing to know. Okay, another really simple example of making something new would be like burning a piece of paper here with a flame. Okay, and the new substance, if you can see it there, hopefully a little easy. The new substance is that that black stuff on there, which is essentially ash or carbon. This is just pure carbon, which is just carbon, cellulose, and any paper. And that burning it created the basically pure elemental form of carbon in the form of that ash. It also created smoke and a smell and a different. So what a color change, but again, in this situation, a color change is a chemical change. Okay? All right, let's take a real quick look at what we had before. All right, so the steel wool, it's not gray anymore. It is now a reddish color, and some kids will call that rusting. It's actually a replacement reaction. We're actually creating copper, because copper was in that blue solution. And if you notice now, that solution is much less blue. It's much less blue than what we started off with. And look how blue that was, right? And so again, this is a color change, but this time we're creating something new, something different, okay? Not creating it from nothing. The copper is coming from that blue solution inside there, copper sulfate. After a while, this solution will actually kind of run kind of clear, maybe a little bit of a dirty, clear color to it, and all the blue will be gone, but all the blue will go in there and react with the iron that's on there. All right, hopefully that makes a little bit more sense with chemical versus physical properties in chemistry.